All right. So this is from 5.4 in your book. Find this. This is the type of application we'll focus on. Finding the dimensions of something these are 3D objects, and it's related to volume. You're going to be given the volume, and then you find the dimensions. So we'll just do one example, and I'll summarize. This is the kind of thing you're going to keep seeing. So what should the outer dimensions be? And I'm going to draw the three-dimensional figure in a second. What should the outer dimensions be to hold 36 feet cubed of water? And we'll skip what the actual thing is. It could be a planter box, it could be a fountain, it could be anything of water. And so since we're able to deal with cubic functions now in this unit, we could only go up to quadratic before, so we were limited to just area and 2 dimensions with the last unit in quadratics, but now we can do much higher degrees. So volume will just be 3rd degree. We won't go any higher than that for our application. So I'll do my best, even though I often am happy that I'm not a geometry teacher, because then I can avoid drawing things like this. But I'm going to do my best to draw a this is called a rectangular prism. So there we go. Now it's not a solid here. You want to hold water inside, and the other thing about the problem is the walls of this are 1 foot thick. The walls are 1 foot thick, which will make it more interesting. 1 foot thick and open at the top. So I'm going to draw this little thing here to show that it's open there. So it's basically like, think of a planter box. Yeah. I would say a box of tissue, but then those don't have thick walls with a tissue box. So okay, so, and you're given that these sides, this side is x by x and this is twice x. Okay, so there was actually one like this on in the worksheet that you did a little while back. So to represent the volume, you would, and then I'll explain why it's this polynomial, and then we'll solve it. You would use 2x minus 2 times x minus 2 times x minus 1 equals 36. And so let me explain why you're given this volume of 36. That's where that comes from. This is because if the length of this side is 2x minus 2, because remember the walls are 1 foot thick, so that's 1 and that's 1 right there. So this the space that holds the water is 2x minus 2. That's this dimension. And then this, for the same reason, this is x minus 2, because these are length 1. So that's x minus 2, and then this is the height right here. And why is the height just x minus 1 instead of x minus 2?
Because the thickness of the bottom is just
Good, Graciela. Now you're in the video. Because the bottom of it is a foot thick, but the top is open, so you would just use x minus 1 for the height right here. That would be the trick to that. And now we just use the skills we have already to solve this. We need to get x by itself, but we can't use. Why can't we use the zero product property straight away? Yeah, because it's equal to 36 right now. I got to fix that. So before you start the problem, you have to distribute everything out and get it equal to 0. All right. So We're going to start by doing the distributive property on these two. Distribute the 2x and distribute the negative 2. So you get 2x squared minus 4x minus 2x plus 4. And then I'll just copy the rest. Because we have to multiply these two together and simplify and then multiply by the last one. So now we have 2x squared minus 6x plus 4 times x minus 1 equals 36. And we have to, now you distribute each of these three terms to these two for a total of how many terms? You have to distribute each of these three to each of these two for a total of 6 terms. Thanks, Ben. 2x squared times x is 2x cubed. 2x squared times negative 1 is minus 2x squared. That's done. Now we distribute the negative 6x to both of these. Negative 6x times x is negative 6x squared. Negative 6x times negative 1 is plus 6x. That's done. Now we distribute the 4 to both of these. So plus 4x minus 4 equals 36. Now you know why we have to practice combining like terms, because we need to simplify this side, otherwise it's too messy. So we only have one cubic term, so 2x cubed stays. We have negative 2x squared minus 6x squared is minus 8x squared. You have 6x plus 4x is 10x plus 10x. And then I'm going to subtract 36 from each side because I want to use the ZPP. So minus 40 equals 0. Okay, and now we're using all the skills from this whole chapter to do this. Now we factor, right? That's the only way we could solve this. The easiest way, what's the technique when you have 4 terms? Grouping. Always try that first. If grouping doesn't work, then you're going to have to do your synthetic division and try the different factors. Alright, so we group these together and we group these together. The GCF here is 2x squared, so we take that out. And that leaves us with x minus 4. And whew, thank goodness this is going to work. The GCF here is plus 10 times x minus 4. Thank goodness these are the same, because now I just factor the x minus 4 out. And I've got 2x squared plus 10 left over. And that is almost there. So now I have to use the ZPP and set each one equal to 0. So, yeah, ZPP is 0 product property. So x minus 4 equals 0. X is 4. That sounds like it could be a reasonable answer. Then, and you're going to do this in your homework tonight, you try to solve this. So I want to get x squared alone. Divide by 2. Oh my goodness. I take the square root and I have plus or minus the square root of a negative number, which happens to be plus or minus I root 5, but that does not help me at all. So yes, it is a solution, but it's an imaginary solution and it has no relevance in this problem. So I don't use it at all. I use the 4. I want to use what helps me, what makes sense. So we go back to the original question, which is you always have to go back, okay? What should the outer dimensions be to hold 36 feet cubed of water? The outer dimensions and the expressions for so the outer dimensions, always answer with a complete sentence. The outer dimensions are, well, the expressions are 2x by x by x, but we know that x is 4. We're going to use this. So the outer dimensions are what? So 8 by 4 by 4 feet. If we just plug 4 into all those expressions, into 2x, x, and x, the outer dimensions are 8 by 4 by 4 feet. Just a sanity check, if you multiplied all those together, 8 times 4, 32 times 4 is 120 something. Okay, so does that sound somewhat reasonable? Yeah, that the total volume would be something like 120 something, because we only need to hold 36 feet cubed, so the total volume is going to be bigger. All right.